Hi everyone, welcome back to my channel. In this video, we'll solve a very nice identity which is 1 cube plus 2 cube plus up to n cube is equal to n into n plus 1 by 2 whole square. So we'll prove this identity by using mathematical induction. First, we denote the above identity by Pn. So let Pn denote the above identity. And we need to prove Pn is true for every n. Okay, so for that, we check for n equal to 1. So for n equal to 1, we have LHS is 1 cube, which is 1. And we have RHS, if we put 1 instead of n, so we have 1 into 1 plus 2 by 2 whole square. So it is nothing but 1. So from here, we can conclude LHS equal to RHS, and that will imply that P1 is true. Now by mathematical induction, we will let Pn is true. Then by using this statement Pn is true, we will try to prove P of n plus 1 is also true. Then by mathematical induction, we can say that P of n is true for every n. So for that, first consider P of n plus 1. So P of n plus 1 is what? We need to prove 1 cube plus 2 cube 2 n plus 1 cube is equal to, if we put n plus 1 instead of n, so you get n plus 1 into n plus 2 by 2 whole square. Okay, so consider 1 cube plus 2 cube up to n plus 1 cube. So we can write this expression as 1 cube plus 2 cube up to n cube plus n plus 1 cube. So first, this sum is already we know by the induction statement. So we have Pn is 2, so we have 1 cube plus 2 cube up to n cube is equal to n into n plus 1 by 2 whole square. So by induction argument, we can write it as n into n plus 1 by 2 whole square, and we have here n plus 1 whole square, sorry, cube. Okay, so here we can take common n plus 1 whole square. So then we have in the first term we have n square by 4 plus here it is n plus 1. So if we simplify this, we have n plus 1 whole square, it is n square plus 4n plus 4 by 4. And we know that the expression in the bracket is nothing but n plus 2 whole square and 4 is nothing but 2 square. So we can write this as n plus 1 n plus 2 by 2 whole square. So we get that P of n plus 1 is 2. So what we get so far? So P1 is 2, and if we assume that Pn is 2, then that will imply P of n plus 1 is 2. From this 2, by mathematical induction, we say that Pn is true for every n. And that proves our identity. 1 cube plus 2 cube up to n cube is nothing but n into n plus 1 by 2 whole square.